Welcome to AulaUE. Today we are going to talk about hypothesis testing. Let's suppose that we want to solve the following problem. The dissolved oxygen concentration at TBA is 20 milligrams divided by 100 millimeters. A sample of 40 streams is considered. The results are the following ones. Question: is there evidence that this sample is comparable with the population at alpha 0.05? Okay, first of all, I'm going to copy the given data. X bar is equal to 18.50, S is equal to 4, so let me just notice that sigma is unknown, and so we have to employ the t-distribution in order to compute the test statistic. N is equal to 40 and alpha is 0.05. Okay, the first step, it's going to be just to define both the null hypothesis and the alternative one. So for this particular example, we just need to notice that we want to test if the dissolved oxygen concentration at TBA is 20 milligrams per 100 millimeters. So the null hypothesis, it's going to be mu, the population mean, equals to 20, and the alternative one, it's going to be mu different from 20. So we are dealing in this particular case with a two-side test because that's given from the alternative hypothesis being different from, okay? The second step is going to be to calculate, to compute the test statistic. And as I said, since sigma is unknown, in this particular case, we have to calculate a test statistic that follows a t-distribution. So I'm going to employ capital T letter for the test statistic, which is x bar minus mu divided by s over square root of n. And this particular example is just 18.5 minus 20 divided by 4 over square root of 40. If we operate a little bit, we get the capital T is just minus 2.37. This is the value of the test statistic, and then we can just go on. The third step, step number 3, is going to be just to define the rejection region. Okay, to do so, we just can do a plot and a sketch of the rejection region as follows. We just do the sketch of a t-distribution, and we just notice that we need to calculate two different values, okay, for the left part and the right part. So we just need to calculate alpha halves. Since alpha is 0.05, of course alpha halves is just 0.025. And we just need to calculate the value for t alpha halves and minus 1. So t of 0.025, 39. That is equal to approximately to 2.223. So 2.023 is a value that we take t alpha halves and minus 1 in the right part. And of course, in the left part, it's going to be just the same quantity, but with a negative value. So it's going to be minus 2.023. And these are the two values that define the rejection region. So the rejection region for this particular example goes from minus infinity up to minus 2.023, and then from 2.023 up to infinity. I just put it here in blue. Okay, the rejection region. Let me just notice that for this particular example, capital T, the test statistic, minus 2.37 is just inside the rejection region. As you can see, we plotted in the graph, and we see that minus 2.37 is, of course, smaller than minus 2.023, the value of minus t alpha halves and minus 1. And hence, we see that the test statistic is inside the rejection region. Okay, what happened? If the test statistic is just inside the rejection region, we just need to reject the null hypothesis. Okay, that is the conclusion for the problem, the mathematical conclusion. We reject the null hypothesis. And now we just need to answer, of course, the question from this problem. So the conclusion, since we reject the null hypothesis, is that therefore there is no evidence to support the assumption, okay? In this case, there is no evidence to conclude that the dissolved oxygen concentration at TBA is equal to 20, okay? And that will be the final answer for this particular example. Okay, that's all for today. I hope you enjoyed this video.